Okay, we're moving on to 6.7, graphing linear inequalities in two variables. We'll go back and do 6.5 and 6.6 after the NORAMs when I can have more contact with you. Your assignment comes from the book, page 409, 379, 13. 16 is a little challenging. It's good, though. It's a multiple choice question, so think about how you can sometimes eliminate choices with a multiple choice question, and then these numbers here. So the first couple are pretty straightforward. It just says tell if the ordered pair given is a solution to this inequality. So I just want to see if it works. Does it work? I check. This is my x value. This is my y value. So I'm just going to substitute, and I get 18 minus 10 is less than 12, and 8 is less than 12. Check it's a solution. You could say true, or you could write the word solution. Any of those are acceptable as far as I'm concerned. The next thing we're going to do is really the meat of this section, and it's about graphing inequality. Change the inequality to an equation in order to graph the boundary. The boundary will be a line that is dashed if you have less than or greater than, and solid if you have less than or equal. We'll talk more about that, but this is basically the rule. That it be equal to solid the line if it can. And some shading, and the most effective way to determine which shade to test point. This is a good review. Here's some inequality. The first thing I'm going to do is let's some call equation, and I'll point as minus, and if x is 3, 3 minus 2, 0, 2, and 3, 1. Indicate on both the x and the y. Now, since I equal solid line, negative 2 is equal to this. So 0, oops, y is negative 2 is less, 2. Negative 2 is less than or equal if this is just a less than. If I have negative 2 is less than 2, or since I can equal 2, these points are part of my therefore I have a solid line. Now shade and a test 0, 0, not on our line. We test center equal to 0 minus 2, 0 less than or so. Does this work? No. Should 0, 0 be part of the solution? So line, because I can be equal to, and when would say this. I'm not going to take the time. Like 2 negative. It were okay. Remind you how to deal with standard eyes and then graph. But so again, we're going to graph x is equal to 16 x, and if y was 0, x would have to be 2, and then 16 I'll go by 2, 2, 8, 10, 6, there's this can't be equal to, so that has 16 is not greater than my back. So that has to be dashed. I'm gonna test 0. Zero greater than 16? No. So do I want and again, no point on this line will satisfy. A couple more reminders about horizontal and vertical. 5. I don't care what y is. -5 if I'm x. And so, and you don't really need to test a point here. We can tell these are all. My boundary is the x value of net. Since I can't be equal to 2, so I'm going to shade below. The division y divided by 2 is greater than is by itself. I'm going to multiply both sides by 2. And then I'm going to change it to an equation. I'll make it x is 0. X is 0. 2 is 14. 14 minus 4. And here I'll just 1, 4, 5, 7, not greater than, not equal to, so I'm gonna have to dash but it should be a straight edge. I can't too. And this sorry. The original equation is 0, 7, no. Is not part of the solution. As zero doesn't work. And what I was gonna say, that works. And y is 14. Is 15.